Hello out there and welcome to Peter's online tutor. Today we shall be looking at physics. The topic here is conversion of galvanometer to ammeter. Now there's a question on the board, JAM 2006. It reads, an ammeter of resistance 5 volts has a full-scale deflection when a current of 50 milliampere flows in it. The value of the resistor required to adapt to measure a current of 5 ampere is question. Now, how do you solve a question like this? A question, that has to do with what? Conversion of galvanometer to ammeter. Now, before we solve this question, there is something I want to quickly explain. Let's look at this diagram. Look at this. If you are converting a galvanometer to an ammeter, the galvanometer, also known as what a moving coil meter, is connected in parallel to a low resistance wire known as the shunt. Okay, I take it again. The galvanometer is connected in parallel to a low resistance wire known as the shunt. Now, this is the galvanometer. Okay, now there is a current. Okay, that the galvanometer has. So I'm going to write it as IG. Okay. Now the galvanometer also has its resistance. I'll write what RG to represent the galvanometer with resistance. Now this is the low resistance wire known as the what? The shunt. Okay. Now I'm going to put RS here to represent the shunt resistance. Now apart from that, there is a current. There is a current that flows into the what? The shunt resistance. I'm going to write it as IS. So IS is the shunt current. Okay. Now there is a current here. Okay, there's a current here from the ammeter. That has been converted to what? The galvanometer that moves into this particular circuit. Now as it gets here, it splits into two. So I now is equal to what? IG plus what? Plus IS. Now remember, since the galvanometer and the shunt resistance are connected in parallel, it means their currents are not the same, but they have the same potential difference. Okay, so from here I can write it as this. So my VG is equal to what? VS. VG represents what? The PD of the galvanometer. Now VS represents the what? The PD of the shunt. They are going to be the same because they're in parallel. Now, DG here from Ohm's law becomes IG RG. Okay? My VS here becomes IS RS. Okay? Then note also that because they are in parallel, current is not the same. So I can come here and write I equals IG plus IS. Okay? So it shows that the currents across the what? The galvanometer plus the current across the shunt to give us what? The total current, which is what? I. Alright? So if that is clear, let's now solve this question. Okay? Now, an ammeter of resistance what? 5 ohm. Okay, so we are using the word the galvanometer here. So it shows that my RG equals to what? Equals to 5 volts. So RG is 5 volts. Okay? Now, has a full-scale deflection when a current of 50 milliampere flows through it. This is the what? The galvanometer current. Okay, so it is what? 50 milliwatt ampere. So I'm going to write 50 milliampere. Okay, 50 milliampere. Now, the value of the resistor required to adapt to measure a current of 5 ampere. So the 5 ampere here is the what? The total what? Current here. All right, and then from here, we are now asked to find the resistance of the shunt. Okay, based on what we're having here, the value of the resistor required to adapt to measure. So our RS is what? Unknown. All right. Now let's now come back here. If we look at what we are having here, our IG is given, our RG is given, our IS is not known, is not given, but our RS is what we are asked to find. All right, so we're having two unknown here. Now, what do we do in a case like this? So the best thing for us to do is to find our what? Our IS from here. Because this one is given, this one too is given. I equals IG plus what? IS. All right. So let's take it from here. Now from here, I'm going to be having my I equals IG plus IS. My I here is my 5. Okay. My IG here is a 50 milliampere. So we convert 50 milliampere now. So we divide 50 by 1000. Okay. So plus what? IS. All right. So here gives us 5 equals 0 cancel 0. If we divide 5 by 100, we get 0 0.05 plus what? IS. Okay. So this comes here. So it means my IS now is equals to 5 minus 0 0.05. Okay. So that should give us 4.95 ampere. So we now have the current across the shunt. Okay, so we can now calculate what our RS as the shunt resistance. Okay, now let's do this. So it's going to be from here, IG RG equals to what? IS RS. Now IG is what? This 0 0.05, 0 0.05 times RG here is 5 ohm, and IS now is this 4.95, 4.95 times what? My R what? S. Okay. Now divide both sides by 4.95, both sides by 4.95. Therefore, my RS now equals 0 0.05 times 5 over 4.95. RS now is equal to, now let us say the value of the resistance of the shunt, or the shunt resistance is 0 0.05. Right? So if you love what you have seen so far, kindly click on the subscription button and like this video. Come again the next time. Take care of yourself and bye bye.